Okay, hello everybody. I want to give you a quick update on where we're at with design work for the car and basically where this project's at. Lately, the focus has been on finishing the engineering for the steering, and we actually made it work within SolidWorks now, so that if you grab the steering wheel and you turn the wheels, actually you turn the right way, we got about a 15-to-1 ratio, 15 degrees of wheel movement, steering wheel movement, gives us 1 degree of kingpin movement, or steering radius change. This box here is just a fake box. It's not anything other than a plain box, but to keep the model simple, this actually be a 2-to-1 gear a quickener that you can run in reverse and get that so that it actually slows the steering down some more. I think at the speeds that we're going, we probably want to try to slow the steering down some more, and that will give us the 15-to-1, 150 degrees lock to lock to get us 10 degrees of wheel movement, 5 degrees each direction. The tie rod on the bottom connecting the two of them. The drag link, or the steering rod, this would be the drag link, or there's no drag link on this particular model, but the steering rod is perpendicular to the axis of travel for the spindle as the suspension travel moves up and down. So there should be very little bump steer when the suspension is actuated. You can see the actuation through here. This is a hydraulic cylinder, and this slides up and down in this cavity here. It's designed for 1 inch of travel. It'll sit a 1/4 inch into travel when it's sitting there at static weight on the starting line ready to go, and it'll compress down about another 1/4 inch once at speed at 500 miles an hour. It'll drop down another 1/4 inch. Again, you can see the wheel movement. You can see everything else turn here if we grab the wheel and shake it. I don't think it's going to stay like this. I think we're going to bring another rod or something else off of this bar here and this bar here, coming in at an angle such like this, and support this rod. That way it gives us more crush zone if the car gets hit. If it gets hit any further than that, harder in the front, I'm going to have a giant collar in the back here that's also going to double as a steering limiter to limit the degrees of wheel movement to 150, and that will also stop it from pushing this bar through, moving all these bars through into the cabin, into my face in event of a crash. You can see back here, all the engineering's done for the pumps. This tank is complete, mounted with the radiator. That tank's all done. All it doesn't need is finish welded. This tank here is the oil tank. This tank here is the fuel tank. Both these tanks are complete. This back here is the front parachute box and the rear parachute box. The front parachute box is all water jet cut out, but not bent up and welded yet. These side plates here to go on the Winner's Streamliner are cut out, and they fit on the rear axle. It also has spacers that fit in here to keep it away from the center section and all the other the casting, because they're spot faces and they're going to sit on its spot faces. These pieces are done, so we're going to very close to actually the mid plate is done, and I double check that to make sure it fits on the motor. Thanks to JD on, he gave me the information on all the specs for where all these holes got to be. You see them highlighted in orange there. So as far as engineering goes, I'd say we're coming up on 95% of the way done. It's just little stuff here from here on out. That's it.